1. All right. This question is question number 10 from the June 2017 paper. Here's what it says. P, Q, R, and S are 4 points on the circumference of a circle, of the circle shown below. Angle QRS is equal to 58 degrees. Using the geometrical properties of a circle to give reasons for each step of your answer, determine the measure of angle SPQ. All right, so the first thing we need to do is identify this angle. It's angle SPQ. All right, whenever 3 letters are used to reference an angle, the angle is always at the letter in the middle. Whenever 3 letters are used to reference an angle, the angle is always at the letter in the middle. So this is the angle that we want to find. All right. Now, if you look carefully, you can see that PQRS is a cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral in which all 4 vertices are touching the circumference. It is drawn inside the circle and all 4 vertices are touching the circumference. Opposite angles of a cyclic quadrilateral are supplementary. So opposite angles, the angle at P and the angle at R are supplementary, that is, they add up to 180 degrees. So angle SPQ would be equal to 180 degrees minus 58 degrees. And that would be equal to 122 degrees. And what is the reason for this? They're opposite angles of a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral are supplementary, that is, they add up to 180 degrees. II. Now in II, we're asked to calculate, determine the size of angle OQS. Angle OQS. OQ and then S. So this is the angle they're talking about. All right, let's label the angle theta. Now, the line OQ is a radius of a circle. The line OS is also another radius. So triangle OQS is an isosceles triangle. This is radius. This is radius. Now, if OQS is an isosceles triangle, the 2 base angles, the one at Q and the one at S, are equal, because the base angles of an isosceles triangle are equal. Let us determine the size of the angle here. All right, let's call it angle, let's say alpha. So alpha would be equal to 58 degrees multiplied by 2, which is 116 degrees. And the reason for that is the angle at the center is equal to 2 times the angle at the circumference. All right. So this angle here is 116 degrees. And the 3 interior angles in a triangle add up to 180 degrees. It means therefore that theta plus 116 degrees would be equal to 180 degrees. And the reason for that is that they are the interior angles of an isosceles triangle. So 2 theta would be equal to 180 minus 116 degrees. 2 theta would be equal to 32 degrees. Let's divide both sides by 2. So theta, which is angle O, which is angle OQS, would be equal to, alright, sorry, made an error here. This should be 64. Getting ahead of myself. So the angle here is actually 64 degrees. So this angle, 180 minus 116, that's 64 degrees. Divide both sides by 2, you're going to get 32 degrees. So angle OQS is equal to 32 degrees. All right, let's get to the B part of the question. All right, this question is a bearing question, and it says a ship leaves port A and sails 52 kilometers on a bearing of 044 degrees to port B. So a ship leaves A, this is north, and sails on a bearing of 44 degrees. It sails a total of 52 kilometers on that bearing until it gets to the port B. Now at B, the ship then changes course to sail to C, which is 72 kilometers away on a bearing of 105 degrees. So at B, it then changes direction, and the direction it changes direction and going to bearing now of 105 degrees. So there's 105 degrees, and it's in order to sail to C, which is 75 kilometers away. All right. So the next thing we're asked to do is we're asked, first it says I on the diagram below, not drawn to scale, label the known distances traveled and the known angles. So we did that. We know that this angle here is 44 degrees. The angle here is 105 degrees. And the distances are 52 kilometers and 75 kilometers. Next, we're asked to determine the size of angle ABC. So we're asked to determine the size of angle ABC. So this is the angle here that they're asking us to find. All right. Well, to find out, basically, we're going to have to find it indirectly. We're going to have to find the two pieces and then add them together. Let's call this piece theta, and let's call this piece alpha. All right. Remember that two north-south lines are parallel. So this north-south line here and this north-south line are parallel, and the line AB would be a transversal. If that is the case, it means that theta would be equal to 44 degrees. And the reason for that is that they are alternate angles. All right. Alternate angles or Z angles. So that's that here. All right. So theta is equal to 44 degrees. So this angle here is also 44 degrees. And the reason for that, you have alternate or Z angles. Now, alpha and the 105 degrees form a straight line. So alpha would be equal to 180 minus 105 degrees. And the reason for that is that they are angles on a straight line. Angles on a straight line add up to 180 degrees. So alpha would be 75 degrees. So this angle here is 75 degrees. Therefore, angle ABC would be equal to 44 degrees plus 75 5 degrees, and this would make it 119 degrees. So angle ABC is equal to 119 degrees. All right. So the next thing we're asked to do is we're asked to calculate to the nearest kilometer the distance AC. So let's call this distance X. AC, let's call that distance X. All right, if you look carefully, you can see that ABC is a non-right angle triangle, and I know the length of two sides. AB is 52 kilometers, BC is 72 kilometers, and the inclusive angle between those two sides, angle ABC, is 190 degrees. Ladies and gentlemen, if you know two sides of a non-right angle triangle and the inclusive angle, and you wish to find the length of the third side, you must use the cosine rule. Now, cosine rule says a square is equal to b square plus c square minus 2bc cosine a. Now, in the cosine rule formula, a is the side opposite the inclusive angle. So a, from this information here, a would be x, so that's x squared. B and C are the other two sides of the triangle, so that would be 52 squared plus 72 squared minus 2 times 52 times 72 times the cosine of capital A. And capital A would be the inclusive angle, which is 119 degrees. Now, if you put all this information here in your calculator, you're going to get that x squared is equal to 11,518.25444. Now, what we're interested in to find is x. So x, the opposite of square is square root, would be the square root of all of that. 11,518.25444. So therefore, x, which is AC, would actually be equal to 107 kilometers, and that is to the nearest kilometer. Ladies and gentlemen, AC, x, which is AC, is 107 kilometers to the nearest kilometer. All right. In the final part of the question, we're asked to show that the bearing of A from C to the nearest degree is 260 degrees. All right. So let us show the angle that indicates the bearing of A from C. All right. So since I'm given bearing from C, at C, I'm going to go and draw my north, south, east, west line. That's north. All right. Bearing is measured clockwise from north. So I'm going to start from north and come around until I get to the line that connects A and C. Now that angle here, represented by the arc I just drew, represents, or that angle indicates the bearing of A from C. So we need to find that angle. All right. Well, I'm guessing if I knew this angle here, I could simply just take that away from 360 angles at a point to determine the bearing of A from C. All right, that angle, let's divide it up into two pieces. Let's call the internal piece beta and call this piece up here gamma. All right, again, if you look carefully, you can see that gamma is equal to 75 degrees. And the reason for that is that they are alternate or Z angles. They're alternate angles. So you can see it here. That's my Z. All right. These two angles here are both 75 degrees. They're alternate angles. Now, beta, on the other hand, now to find beta, we're going to have to use the sine rule. How do I know that? Well, after you use the cosine rule on a triangle, the next rule to find something more about the triangle, you must use the sine rule. So because I just used the cosine rule, I know I'm going to have to use the sine rule. So I want to find beta, so I'm going to start with beta. Sine beta over the side that is opposite from beta, which is 52, is equal to the sine of the only other angle in the triangle, 190 degrees, over the side that is opposite to that, which is 107. If I multiply both sides by 52, I'm going to get sine beta is equal to 52 sine 119 divided by 107. All right. And to 3 decimal places, that is going to be equal to 0.425. Just put it in a calculator, press equal, and give your answer to 3 decimal places. Now, if I know the sine of an angle, to find the angle, I must use sine inverse. So beta would be equal to sine inverse 0.425. So beta would be equal to 25 degrees, and that is to the nearest degree. Now, so the angle alpha is 75 degrees, and beta is 75 degrees. Sorry, beta is 25 degrees. And the three angles together here form angles at a point. Angles at a point add up to 360 degrees. So therefore, let's turn the page. Therefore, the bearing of A from C would be equal to 360 minus 25, which is beta, plus 75 degrees, which is gamma. And the reason for that is that these are angles at a point. So this would be equal to 360 minus 100. So the answer would be 260 degrees. So essentially, that brings us to the end of the question, because we were asked to show that the bearing of A from C to the nearest degree is 260 degrees. All right, which you just did. The bearing of A from C is 216 degrees.